In this problem, we have to find the domain of the relation y. This is equal to 1 by log 1 minus x base 10 plus root over of x plus 2. And 4 options are given here. We first take the function y is the sum of two functions. For relation y, sum of two relations, this is f of x and this is g of x. And we know that in this type of function, the domain of y is given by domain of f intersection domain of g. That is the domain in where two functions, both the functions are defined. Now for the function f, this is f, we must have this function is defined only when 1 minus x, this is greater than 0. Also 1 minus x, this is not equal to 1, because if this is equal to 1, then log 1 minus x is 10, this is 0, so 1 by 0 is undefined. Also log is always defined when 1 minus x is greater than 0, that is x less than 1 and x not equal to 0. This is for the first function. So we write domain of f is minus infinity to 1 minus 0, excluding 0. And for the second function, g root x plus 2. Clearly this function is defined only when x plus 2 greater or equal to 0, that is x greater or equal to minus 2. So domain of g is given by minus 2 to infinity. Now from the real line, this is 0, this is minus infinity, this is infinity. If we draw df, then we get this is 1, this is minus infinity, so excluding 1 and excluding 0 also, excluding 1 and excluding 0, this is 1, this is 0, and dg, this is minus 1, this is minus 2, and this is given by this is infinity, this is minus 2. So the common position or intersection df intersection dg is given by from minus 2 to 1, but excluding 0. Right? So here we see the option C is correct, because minus 2, 1 excluding 0. So C is the correct option. Okay, thank you for watching.